All right, friends and neighbors, welcome back. As you know, we've completed all of our chapter videos. That includes Volume 1 and Volume 2. So I thought I would go back and put together some review materials as we get ready to take the exam. So these are going to be the Do I Know This Already questions for chapters 1 through 10. And that gets us up to about a half an hour. So I'll do a couple of these, and then we'll be ready. So this is the chapter 1, Do I Know This Already? Questions. Which of the following protocols are examples of TCP/IP transport layer protocols? And remember, in chapter 1, it's the overview. So a lot of this stuff is not actually directly on the test until you get to that particular chapter. But the answers for this one, transport layer protocols, are D and F, UDP and TCP. Question number 2, which of the following protocols are examples of the TCP/IP data link layer protocols? Well, these are going to be our local area network protocols, right? Layer 1 and layer 2. So that was A and G, Ethernet and 802.11. Question number 3, the process of HTTP asking TCP to send some data and making sure that it's received correctly is an example of what? So this is HTTP at the application layer and then TCP at layer 4. So that was adjacent layer interaction, B. Question number 4, the process of TCP on one computer, marking a TCP segment as segment 1, and the receiving computer then acknowledging the receipt of TCP segment 1 is an example of what? Well, that was B, same layer interaction, right? TCP to TCP. Question number 5, the process of a web server adding a TCP header to contents of a web page, followed by adding an IP header, and then adding the data link header and trailer is an example of what? That's A, data encapsulation. Question number 6, which of the following terms is used to specifically identify the entity created when encapsulating data inside a data link layer headers and the trailer? That is a frame. So that's D. So we got frames, packets, and then segments. Now I thought it might be kind of fun to do the Did I Know This Already set of questions at the beginning of the chapter. Of course, I aced it, but there were a couple of tricky spots in there. So let's do a reading from the book. All right, so question number 1. Some end user devices connect to a LAN using a cable while others use wireless. Absolutely true. Which answer best describes which devices use Ethernet to connect to the LAN? Now the key here is that Ethernet is a wired technology. So the answer to that one, let me see, what letter was that? Only the end user devices that use cables are using Ethernet. Because if they were doing wireless, they'd be doing 802.11, and that is not Ethernet. Question number 2. Which of the following Ethernet standards defines the gigabit over UTP cabling? Well, we've got answers here of 10 G base T, 100 base T, 1000 base T, and none of the above. It's 1000 base T. 1000 base T is 1000 megabits or 1 gigabit per second. Which of the following is true about Ethernet crossover cables for fast Ethernet? Pin 1 and 2 are reversed. I'm not even going to read all these. Pins 2 and 3 or pins 1 and 2 go to pins 3 and 6. So that was the answer there. I'll show you that in the pinouts later on in the chapter. Question number 4, each answer lists 2 types of devices used in a 100 base T network. If these devices were connected using UTP cables, that's unshielded twisted pair, which pairs of devices would require a straight-through cable? This is actually pretty straightforward. Anything that acts like a PC needs a straight-through. So if you go PC to a switch, PC to a hub, router to a hub, router to a switch, those require straight-through cables. Anytime you're going to connect to a switch or a router or a PC to a PC, you're going to use a crossover. Of course, today they auto negotiate, but that's the answer to the question. What are the advantages of using multi-mode fiber? Well, the key to this one was that you had to realize what kinds of devices or what kinds of module used multi-mode versus single mode, and then also the distance thing. So the nice thing about fiber is that it goes longer than UTP, much longer. But you had to know also that multi-mode fiber uses an LED versus single mode, which often uses lasers, and so they stuck those in there. So you got to be aware of that one. Which of the following is true of CSMA CD? Now, CSMA CD, if you didn't know, That is the carrier sense multiple access with collision detection. That's the access method. It's how Ethernet nodes decide whether or not it's okay to transmit. In CSMA CD, it doesn't prevent collisions, it just detects them, so collisions can happen. So that was the answer there. Which of the following is true about the frame check sequence? Well, it's all the way at the end of the frame. It's not a preamble or what we might call a header. It's a trailer. It goes at the end of the frame, and that is the frame check sequence. It's also a cyclical redundancy check 32, which makes it 4 bytes. Which of the following is true about the format of Ethernet addresses? Now, this was a little bit tricky as well. The OUI, or Organizational Unique ID, is in the front part of the MAC address. And again, I'll show you some examples later on, but it's the first 3 bytes. But you might also go, wait a minute, isn't that the first half? Well, you had to know, of course, that a MAC address is, well, 6 bytes long, and then the first half is 3 bytes. So it was a little tricky there. So if you whiffed on that one, I totally get it. Which of the following terms describe Ethernet addresses that can be used to send one frame that is delivered to multiple devices on a LAN? Now, there's 2 answers that were correct here, multicast and broadcast. There's actually 3 flavors of Ethernet or MAC address, the other one being unicast. Okay, that does it for our questions. But of course, what we're going to do first is, did I know this already set of questions. Now, as we get started here, I have to admit, I got tricked by the wording on some of these questions. It's also interesting that some of these terms are a little dated. They're still on the CCNA exam, so that's why the chapter is covering them. But man, I was like, wait a minute, what are we trying to ask about here? Okay, so the first one, which of the following terms is not commonly used to describe a serial link? Well, there's a bunch of terms, but the one that doesn't really fit is E-line. And that was actually the first place I went, wait, what? Because there is a thing called an E1, but not normally used for, how we talk about a serial link. Now, I'll talk more about what it means to be serial here in a second. Now, this is the one that really got me. 2 routers, R1 and R2, connect using Ethernet WAN service. The service provides point-to-point service between these 2 routers only as a layer 2 Ethernet service. Which of the following are most likely true about this WAN? Choose 2 answers. Well, B and D were the right answers, but I had to puzzle over this one for quite some time just because of the wording. But B and D say R1 will connect to an Ethernet, a physical Ethernet link, and the other end of the cable will be to a device at the WAN service provider, point of presence. Now, the assumption here, I think that the question is making, is that there's a couple of sites that are connecting to the WAN provider, and the routers are not actually connecting directly to each other. And then D was router 1 will forward data link frames to R2 using an Ethernet header or trailer. And I'll actually show you that topology here in just a few minutes. Imagine a network in which PC1 connects to the same Ethernet LAN as router 1. PC2 connects to the same LAN as router 2, and the 2 routers connect to each other with a PPP serial link. Now, the thing that we had to know is what in the world PPP is for. Well, PPP is the point-to-point protocol. Hasn't been used in a little while. The last time I used it was with dial-up networking. And PC1 sends data to PC2. Router 1 removes the Ethernet header and trailer. Which of the following is true? Well, the answer to this one is that router 1 does not use the removed Ethernet header or trailer again. And we will see that routers destroy layer 2 frames and then move on. Okay, so by the way, I thought I would do these questions as a way to help you through this and why the answers are what they are. But if this gets a little dull or it's not as interesting, go ahead and tell me in the comments, and we can skip this part for future chapters. Okay, which of the following does a router normally use when making decisions about routing TCP packets? That one's actually pretty straightforward. We have to process things at layer 3, so that is going to be the destination IP address. We don't worry about the source because we're trying to get to the destination. Which of the following is true about a LAN-connected TCP IP host and its IP routing forwarding choices? Well, so the answer here is C, and what that means is that the host actually has the ability to determine whether or not the destination is on its network or not on its network. And so if the destination is off of the network, that's when it sends it to the default gateway. I'll show you that too. Question number 6, which of the following are functions of a routing protocol? Well, the whole idea, whoops, let's do this. Hopefully I didn't skip one there. No, I think we're good. Okay, in a routing protocol, that's A and C, which means that routing protocols advertise known routes to neighboring routers, and let me see, learning routes as advertised to the router by neighboring routers. In a routing protocol, the whole point is to tell your neighboring routers about what you know, and you learn what they know. So that's why it's A and C. A company implements a TCP/IP network with a PC sitting on an Ethernet LAN. Which of the following protocols and features require PC1 to learn information from another server device? That was the keyword and tricky phrase. All of these are part of a network, but the server that we need answers from is from DNS. Okay, that'll about do it there. Okay, did you know this already? Now remember, if you're new to Cisco or you're new to CLI, these are going to be completely foreign to you, and that's okay. But here we go. In what modes can you give the show MAC address table command choose to? Well, the show MAC address command, and really the show command, is how we get a lot of information from a Cisco device, in this case switches. And some show commands are available in multiple places and some are available only in one. And the modes that we're talking about are the user and enable or privileged modes. So both of these will provide this particular command. Now, one of the distinctions between user mode and enable or privileged mode is that in one place you can look at stuff, and in the other one you can configure stuff or maybe break stuff. And so it doesn't make any sense to give the casual observer the ability to reload the device. And so you have to be in enable or privileged enable mode to do the reload command. What's the difference between Telnet and SSH? Well, when we start talking about secure shell, this is a way to encrypt a terminal session or really what we might say are telnet sessions. So telnet sessions, we shouldn't use those at all, except for demonstration purposes. The password is visible in plain text, the username is visible in plain text, and every keystroke is visible in plain text. SSH secures all of that by encrypting the entire thing. So you can't see the username, you can't see the password, and you can't see the data. What type of memory is used to store the configuration when the switch is up and working? Okay, so for this we have to realize that when we type in commands and we tell a switch or a router how to operate, it goes into volatile memory or RAM, random access memory. That also means that if you power off the switch, the configuration is gone. And so that's where it goes initially. So what command copies the configuration from RAM to NVRAM or non-volatile RAM? And that is the copy running config startup config. Now there were a couple of variations on this theme. Most of it is just syntax. But the order is that you're going to say, I'm going to copy this to this. So that's the order here. And startup config then lives in non-volatile RAM. Okay, a user is in line configuration mode. Which command will place the user in enable mode? So what we're getting to here is that there are a couple of layers or a couple of steps in our configuration or when we're working with the CLI. And exit is one of the options. Exit just moves you up one level, and I'll show you exactly what that means later on. But there are two ways to get you all the way out to just enable, and that is the end command or Control Z. So it turns out that there are a lot of Control plus a letter options that will get you around or allow you to navigate a little bit. All right, time now for do you know this already? Now, some of these questions got a little bit long, so I'll explain as we're going here, and then we'll cover them all in the demo as well. All right, first up, which of the following best describes how a switch decides how to forward a frame for a known MAC address? So there's a couple of things we have to know to answer this question going into this chapter. And that was that, first of all, a switch understands or has a known list of MAC addresses. The second is maybe that there's a table. It turns out that we do tables all over the place and all the time in networking. And so the table is going to have all of those MAC addresses that we already know. So when a switch understands a MAC address already, it just sends the traffic to the particular port to which that MAC address is connected. So that was A. Which of the following describes how a switch with all ports assigned to VLAN 1 forward to a MAC address of all Fs? Couple things we got to know in this one. First of all, by default, all ports in a Cisco switch are connected to VLAN 1. So we had to know that. So that describes a particular behavior, which means that all ports could reach all other ports. And the minute that we have a frame that's got a destination address of all Fs, that's a broadcast MAC address, then it goes out everywhere except for the port that it came in on. Which of the following describes what a switch does with a frame destined for an unknown MAC address? Well, we have to be able to get to all possible nodes. So what a switch does with something that it doesn't understand, in other words, it looks at a MAC address and goes, well, this is not my table, and this is not a broadcast or a multicast. Well, I got to find him. So it blasts it out every port except for the one that it came in on. We call that flooding, and so the behavior is exactly the same as a broadcast frame. Which of the following comparisons does a switch make when deciding whether a new MAC address should be added to its MAC address table? Okay. So we have to remember a couple things. One is that it's a source MAC address table. So I don't care about destination MAC addresses at this point. If I'm going to stick something in my table, I want to know that this was in the source MAC address. That is, it came from a particular node. And then the other thing is whether or not I know it already. And so that's really the big deal there. What facts are displayed by the show interfaces command? Well, this was C. And this was a little bit tricky. It was a little bit long. So the idea was that whether or not a port was up and whether or not one of the ports had a node connected to it, and then whether or not it was a fast Ethernet or a 10 base T Ethernet or a 10 megabit per second. So for this question, you had to realize we're talking about fast Ethernet in this particular kind of switch, that it had a node connected and then it was part of that group. Given the output of show MAC address table dynamic, which of the following is true? Well, that was D. And the tricky part there was whether or not there was more than one switch connected. So if you are looking at the show MAC address table dynamic, we know a couple things. We know that traffic came from a particular node down that line. But we don't know if the switch has been up forever, right? Switch table entries time out. And so it's not that this would be the list of MAC addresses that I knew from the time that I started. We don't retain all that information. And we don't necessarily know that the node is directly connected to that port. It might be several switches away. So that was the tricky part there. Okay, so let's get on to the chapter content. Assuming, even if we knew all this stuff, right, let's talk about how Ethernet switches operate. All right, do you know this already? So question 1, if you have configured an enable secret and then an enable password, which one of these will you have to enter to access privileged exec? Well, this has everything to do with the fact that you've added 2 commands on there that sort of do the same thing, but one of them is secret, and so it's the order of operations that's important here. So it's B, enable secret. That's the more secure way of doing it. What would be a useful way to set up password protection with no usernames? Now, when you are setting up the switch, what we had to remember here is that you can set up a password so that the minute somebody goes to connect, there's a password there, but it's not actually tied to usernames, and that's just with a login on the BTY or a login on the line. In switching from Telnet to SSH, with a previous password of my password, which command would be part of the new configuration choose to? Well, because SSH doesn't allow you to log in without a password and is tied to a username, what you need to do is set that up. That's at the global level. And then you need to tell the switch that you're going to be logging in with local. That is, you're saying to the switch, use the usernames and passwords that are stored locally. Question number 4. For a PC connected to a switch and then to a router that connects to branch offices, what command would allow the engineer to log into the switches with just a password? Couple of parts here. That's why there's so many things to select. First of all, that switch is connected to a router, and then it's connected to branch offices. So there's a lot of networking that goes on here. So we would have to go into a VLAN, give it an IP address, configure a global default gateway, and then we would have a password on the VTY, which is what we would use for SSH or Telnet. Question number 5, if all ports are in VLAN 2 with an address space of 172.16.2.0, which two commands would be required? This is a networking question again. So the first thing that we would need, obviously, is an IP address on the switch. We put that on the VLAN. And then if we want to be able to get to it from everywhere, right? The question was a little bit longer than this. We need a global default gateway. Lastly, which line command tells the switch to wait until a show command's output has been completed before displaying log messages on the screen? If you've worked with consoles before, or the CLI, you know that occasionally logging messages pop up, right? When something happens, the switch spits it up there and then interrupts what you're doing. And so it's really annoying. So logging synchronous will turn this off. All right, do you know this already? So this is a busy slide. And a lot of these questions, right, if you knew the answers to these questions, there's no reason to do the chapter. But of course, it's nice to hear these things a couple of times. So I'm going to do all of the questions like I always do, and then we'll talk about most of these things in the chapter. So a switch port and a PC are connected and both are configured for IEEE auto negotiation. Which answer best describes how the switch chooses or will choose its speed and duplex? So we have to know a couple of things about that, but when you're auto negotiation, I'll show you an example of what the pulses look like, but it's just messages that are going back and forth between the devices. And so both the speed and the duplex will be configured by comparing auto negotiation messages. In which of the following modes of the CLI could you configure the duplex setting for int f0/5? Well, to do this, there's only really one answer. You have all of this stuff, almost all of this stuff, occurs in the interface configuration mode. A switch and a PC are connected. The switch port is configured for IEEE auto negotiation, but the PC is not. Which answer best describes how the switch choose its speed and duplex settings? Well, you have to know a little bit about how this is done. The speed will be determined by the signal. So what ends up happening is that one side that wants to auto negotiate now has to look at the speed at which things are coming and go, yeah, I think that's 100 megabits per second. And whatever speed is chosen, that'll determine the duplex nature of the port. Switch interface gig 101/0/5 has been cabled correctly, but the engineer wants to prevent the interface from being used until the engineer enables it remotely. This was for the weekend work that was going to be done. Which action helps achieve that goal? Well, one of them was disconnect the cable, but if you're remote, then you can't reconnect the cable. So the answer here is that you have to go in and shut down the interface. Then when you remote in, assuming you're not remoting in via that port, you would do a no shut on the interface. An engineer configures a switch with the interface range command and then a description connected to the endpoint device. So that's actually a command. Description connected to an endpoint device. The engineer exits and issues a show running config command. Which answers best describe the related output? Choose two. Well, the interface range command is not part of the output, so that was one of them. And then the other thing is that when you do an interface range command, it goes for a whole bunch of ports, and then if you do a description, it'll be applied to all of those. So that was the answer there. The output from show interface status shows f0/1 in the disabled state. Which of the following is true about int f0/1? Choose three answers. Well, if it's disabled, then it's shut down. So that's what happens. We'll see what that looks like. The interface in the protocol will be down, down, and then you cannot use that port to forward frames. So switch 1 and 2 are connected via 10, 100, 1000 ports. The switch 2 configuration includes speed and duplex commands, which disables the auto negotiation for that port. Which combinations result in a duplex mismatch between switch 1 and switch 2? Choose two. Well, we have to know a couple things here. One is that the speed will determine the duplex nature. And in both cases, the duplex mismatch with an auto configuration port will happen when you have the speed of 10 or 100 and a full duplex, because both of those would result in half duplex. Switch 1 connects via cable to switch 2's gig 1/0/1 port. Which of the following conditions is the most likely to cause switch 1's late collision counter to increment? Well, a good thing to remember is that you don't have collisions in non-shared media or in full duplex. So if you have something with a half duplex ending and the other side is trying to auto negotiate or anything like that, that'll result in the collisions. So it's the duplex mismatch with switch 1 set to half duplex. If you didn't understand what in the world I was talking about, we're going to cover all these things over the course of the video. All right, question number 1 in the Do You Know This Already? In a LAN, which of the following terms best equates to the term VLAN? Well, VLANs live at layer 2. And since they're on switches, that'll be broadcast domain. Now, I'll talk more about that later on. So if you don't remember what broadcast domain is, don't worry about that. Now, there was another answer in there, subnet. That one's close because all the nodes in a VLAN have to be on the same address space, but the best layer 2 thingy that goes along with this is broadcast domain. Question number 2, in a topology with 1 VLAN switch and 3 VLANs configured, how many subnets do you need? Well, at layer 3, VLAN equals subnet or equals network. So if you have 3 VLANs, you better have 3 subnets. Switch 1 sends a frame to switch 2 using 802.1q trunking. Which of the following describes how switch 1 changes the Ethernet frame before forwarding it to switch 2? Well, when you do 802.1q trunking, you stick inside the old frame a new header. You also change the ether type, and that's a 4-byte header that includes the VLAN ID, but the MAC address doesn't change. Question number 4, switch 1 interface F0/5 is configured with switch port mode dynamic auto and is connected to switch 2. Which of the following settings on the switch port mode command on switch 2 would allow the trunking to work? And there were 2 of them, trunk and dynamic desirable. So if you set the port to a trunk, or you said, I'm willing to negotiate this, but I'll wait, I'll see what you're doing, that was dynamic desirable. Question number 5. In a new switch, or when a new switch arrives from Cisco, it has no VLANs and VTP has been disabled. An engineer configures VLAN 22 and name Hannah's VLAN commands and then exit. Which of the following are true? Choose 2. For this one, you had to know what happens when you assign ports to a VLAN or when you don't assign ports. So in this case, show VLAN brief would show the output, and so would show running config. So they would be there. They wouldn't have any ports in them. Question number 6, which of the following commands identify switch interfaces as being trunk interfaces? Well, we could do show interfaces switch port or show interfaces trunk. I'll show you demos of those later on. Question number 7, in a switch that disables VTP, an engineer configures the commands VLAN 30 and shutdown VLAN 30. Which answers could be true about the switch? Choose 2. Well, the weird thing about this one is there's no ports in this VLAN, but the VLANs have been configured, but they're not being used. And so in this case, they'd both appear. The other 2 answers were about forwarding, and that would not work. Question number 8. The show interfaces G1 trunk command provides 3 lists of VLAN IDs. Which items would limit the VLANs that appear in the first of the 3 lists of VLANs? Okay. There's a little bit here in the configuration of the switch, but if you show the allowed VLANs, that'll be a subset of what's on the trunk, not just what's on the switch globally. Question number 1, which of the following port states are stable states used when the spanning tree protocol has completed convergence? Now, there's a couple of things here. Convergence is when the topology is all done figuring out what it is. Now, maybe to preface all of these, if you're trying to go, well, wait a minute, what's spanning tree all about? I sort of say that spanning tree is the save your butt sort of protocol. And that is to say that if you make mistakes or something goes wrong with your layer 2 topology, spanning tree is running by default and saves you. And what it tries to do is figure out what the topology should be. Okay, so it does this convergence thing. That is to say, we've got a topology that's in one state, and then it moves to the next state. That process is called convergence. And so what we want is a stable topology. So the two port states are blocking and forwarding. Those are the two end states. All the other ones are what we call transitional. Question number 2, which of the following bridge IDs wins election as root, assuming that the switches of these or with these bridge IDs are in the same network. So the key to all of this is that the root election is based on the lowest bridge ID. Bridge ID, and I'll say this a bunch of times, but bridge ID is a combination of priority plus MAC address. And so the one with the lowest one wins, and that was C. Question number 3, which of the following are transitory port states used only during the process of STP convergence? Choose 2. So if stable states are blocking and forwarding, the other two are listening and learning. Those are transition states where we don't stay on them for but a couple of seconds. Question number 4, which of the following facts determines how often a non-root bridge or switch sends an STP hello BPDU message? Well, we'll find out that there are several timers associated with spanning tree, and the hello timer is the one that controls this particular message. Question number 5, which of the following RSTP, rapid spanning tree port states, have the same name and purpose as port states in traditional STP? Choose 2. And that was the forwarding and learning states. Those are the same in those two versions of spanning tree. Question number 6, which of the following statements correctly describes a port role that is waiting to take over for another port role? Choose 2. These were A and D. And what we have to realize is that in this case, when a port is blocking, that doesn't mean it's dead. That might mean that it's ready to go. So if you need me, I'm here. Right now I'm blocked, but I'll be ready to change if you need me. And so that's blocked but alternate and blocked but backup. And these two become different kinds of ports when they switch. We'll talk about root and designated ports here in a little bit. Question number 7, what STP or RSTP feature causes an interface to be placed in the forwarding state as soon as the interface is physically active? And that is port fast. Port fast moves us to forwarding really, really quick. And again, if you're confused by any of these, don't sweat it. We're going to do them all and go through the whole thing. Question number 8, which optional STP feature acts as a subset of incoming STP BPDUs to disable the port, but also allows and processes some other STP BPDUs, and that would be root guard. All right, so that's did you know this already, and an explanation a little bit of those. Let's dive into what spanning tree is all about. Question 1 in the do you know this already? Which type value in the spanning tree mode type command uses or enables the use of RSTP? And the answer there is A, rapid PVST. We'll see that again today. Question number 2, examine the output of the show spanning tree VLAN 5 command. Which facts relate to the root bridge ID? Choose 2. Well, if you remember from last time, and we'll see later on that what ends up happening is that the minute you have VLANs, we've got to have some way to indicate that there are VLANs. And one is that in this case, with this VLAN 5, that'll be the system extension, and the base priority will be 32768. Question number 3, with Cisco Rapid PVST Plus, which of the following actions does a switch take to identify which VLAN is described by a BPDU? Choose 3. And this is related to all of the things that we were just talking about. The minute you're doing VLANs and the minute you're doing Rapid PVST Plus, what we're going to do is have some trunks. We're going to have a type length value in the BPDU that indicates the VLAN, and the VLAN ID will be in an extension field. So all of those are related to the fact that we're running per VLAN spanning tree plus, and that we've got trunks. Question number 4, a switch port is in access mode. An attacker replaces the host with a switch. So you unplug the host, put a switch in there, running spanning tree. Which features will result in changing the port to error disabled? Choose 2. And in this case, whether port fast was enabled or not, the minute you got BPDU guard there, and what ends up happening is you get a BPDU, the port will be shut down or disabled. Question number 5, the root guard has acted to disable a port after show commands, which answers list facts related or expected due to the root guard action. Choose 2. Well, this was A and E. The spanning tree port will be in broken, and the interface will still be connected, right? So this is we haven't unplugged or shut down the port, so it's still connected, but it'll be broken. Now we'll see that that's also an iOS version specific thing. So sometimes it'll just show that the port is in an unstable state or that it's listening. Question number 6, interfaces gigabit 01 and G0/2 are configured on the same Ether channel. Which of the following terms is used in the configuration commands? We're going to do this. We'll see that it is the channel group. Question number 7, which combinations of keywords on the channel group interface subcommand on 2 neighboring switches, so you have 2 switches that are connected together, will cause the switches to use the link aggregation protocol to add the link to the Ether channel? Well, what we'll find out is that in the link aggregation control protocol from the IEEE, one or both sides have to be active. Question number 8, a Cisco Catalyst switch needs to send frames over an Ether channel, which describes how the switch balances traffic over the 4 active links. Okay, this has to do with load balancing, and so what we have to realize is that there's a mathematical calculation based on the fields that determines over which link the frame will be sent. So there we go. Okay, so this has been the Do I Know This Already questions from Volume 1, Chapters 1 through 10. Don't forget your practice exams, and there's lots and lots of review material out there, so take advantage of that. And hey, like and subscribe if this helps. On to Chapters 11 and 20. Now, as you get through these chapters, may those packets always reach their destinations. Hopefully these review questions will help you on your way. This is CCNA. You can do this.